think, the third webinar, and this time we want to talk about the 7200 series material, monolithic materials. A short outline. So I want to start with an intro into our product line as a whole, and also point out to our more established, older product lines, so that you see how our R&D process developed over the years and our product development evolved. So you probably know our older established product lines with the key benefits of fast curing, fast firing, ability to bond to existing material, non-wetting against molten metal. So after that, I want to dive into 7000 series very briefly, and then we'll end up with talking about 7200 features, benefits, and then I'll go right into applications and performance. So here you see basically all our product lines that we currently have. And this is what we are selling to customers. We also have a department that makes precast shapes. And we are using materials for those shapes that we are not necessarily selling to end users. So on the very left, that's our Thermbond Formula series, the workhorse. That's where it all started with. We have different materials ranging from 2,200 kilograms per cubic meter to up to 2,900, 3,000 kilograms per cubic meter. And we have different products ranging from mullite to high alumina, bauxite-based, and every product series has basically a ramming mix, a gunning mix, a castable, and a patch mix. Then next to it is the heat break series. It's a 1,300 kilogram lightweight material. And same thing, we have a gunning mix, a castable, and a hand pack kind of ramming material. And all these materials, 2-component phosphate bonded. Then we have the Thermbrake, even lighter, 800 kilograms per cubic meter. And again, same thing, castable, gunning, hand pack. And then a little bit of a different binder system here, the concrete series, also phosphate bonded, but it's used for application concrete repair up to 600 Celsius. And this is also a material that is slightly acid resistant, can be used in an acidity range between 2.5 pH to around 12 and higher. So now the next to it, and this material was developed around 6-7 years ago, and that's our 7000 series. It's a material that can be mixed with water, but it's phosphate bonded. It has a very unique phosphate bond because it's a neutral phosphate bond. So we can use all these additives to make it self-flowing. So we have self-flowing mixes, very high abrasion resistant, but nevertheless fast firing. You can heat up this material relatively quick. Other features, we have silica-free materials that are almost self-flowing for high corrosion applications, like a 97% alumina material, good for gasifier and high sodium corrosion in those applications, or for ammonia plant, everywhere where you need high alumina content silica-free materials. And then on the very right, Thermbond 7200 series. I have to say the 7000 series, we only have castables. So we tried hard to make it a pumpable product or a shotcrete product. 7000 series, some materials can be pumped, but can't be shotcreted, and we also don't have ramming mixes. And because of that lack in our product range, we developed 7200 series, where we wanted to create a product that is very versatile. It's also mixed with water, but you see here two jugs. One jug says 7200 liquid, the other accelerator. So I will get to that on my next slide here. So maximum flexibility. So we wanted to mimic what we had in our old established product lines, that we have the ability to gun, ram, and cast. And so we developed this material with this premises, and we started working on pumping mixes, and then we came to the conclusion, why don't we just add a liquid that turns a castable into a ramming mix, or turns it into a gunning mix. And so we ended up with a material that you can use one bag and you can apply it in different ways. So you can cast it, of course, but you can also gun it by using a 7200 liquid. And the gunning properties and the results are very, very close to a cast material. And we don't have a lot of dust at the nozzle. And it's actually easy to gun with all kind of gunite machines. And you can turn also this castable material into a ramming mix by using 7200 liquid. And of course, you can pump it. And the pumping properties of this material are very good, because we were so focused on our ability to pump and shotcrete that was the center of our development, actually. And we have another feature, you can wet gun it. Wet gun is actually a higher pre-dampen rate, and it's almost like plastic gunning. So you need a higher material airflow to do this wet gunning method. However, you don't have any dust at the nozzle, and if you're in confined space, this can be very helpful, and it reduces the rebound quite a bit. So it's almost like something in between a gunning grade and a shotcrete material. And so, of course, shotcrete, and for shotcrete you need an accelerator. You can use all kind of accelerators, but we have a proven system, so ours works best for overhead and all kind of other applications. All 7200 series are rapid firing materials. And so if you've attended our dry out seminar, we were talking about about how we develop materials for fast firing. So all these materials went through this regime of testing, where we cast large blocks and insert thermocouples, and then we fast fire those and measure the stresses in these blocks to determine how fast can we fire. And all these materials go basically through a program that you see in this shot on the right, where we go up to 200 Celsius, hold for a couple of hours, and then we ramp up 200 Celsius per hour to 600. And if the material does not spoil or badly crack, then it's kind of approved for our 7200 series. So in the field, I would rate our material as between 50 Celsius and maybe 200 Celsius per hour heat up rates. That's possible. Material types and compositions. So over the years, we've developed quite a few materials here. The workhorse is a 7206. It's a 62% alumina material with high mullite content. 7229 is basically the same material, but with 20% silicon carbide. This works well in cement application because the silicon carbide content makes it very corrosion resistant against potassium vapor, sodium vapor attack. It also works well in applications where you have low angle abrasion, like in sills and ramps in the aluminum industry, floors, and it's non-wetting because of its silicon carbide content. 7206N is a 60% alumina material with non-wetting additive. I would not rate this material as good as a Formula 5 or a Formula 4L material in contact with aluminum. The non-wetting properties of those materials where you use additives, non-wetting additives, are just not as good as a phosphate bond. But in applications where you have relatively mild temperatures and you stay below the metal line, it actually works very well. 7209, fire clay chamotte material, also kind of a workhorse material. 7208 is a lightweight material in the range of 80, 90 pounds per cubic foot, and it's used as backup linings. Also in this case, you can hand pack it, you can shotcrete, you can pump it. 7225, it's a very unique material. It's a high thermal shock resistant material. It's a medium weight and relatively good abrasion resistant at less than 8 cc after placement. And it's used in the petrochemical industry mostly. Shotcrete. So when we started with 7000, we bought a shotcrete rig and we were hoping to make a phosphate bonded shotcrete material. Did not work out that well. So we turned to 7200 and used a little bit of a modified binder system. So 7200 binder system is a combination of a colloidal silica with a cement bond. We have green strengths, high green strengths that you normally don't have with colloidal silica, but you also have the flow of colloidal silica and the fast heat up rates. So it's a combination of the two, so that we call it a hybrid bond. Why shotcrete? Why was it so important? Well, with our two component product lines, we were limited to jobs, let's say up to 100 tons, but then it was all gunning. And in the petrochemical industry, no problem, but in power or in cement, you need to have a shotcrete material if you want to penetrate the market. So that was our target. And then on the other hand, we wanted to have, as I said already, all the different installation methods available, and we wanted to make it a fast firing material. And we wanted to make it a high performing material. So we set the bar relatively high. So why shotcrete? Well, large installation possible. Ideal for sidewalls, roof applications. You have little rebound, so usually less than 5%. With our material, no cure. You can fast fire. After the installation, once the material starts setting, you can fire the unit in. Reduce installation time because of the high rates. So no need for form work. It's a continuous working process, and the quality is relatively high compared to, for instance, normally gunning. Although we don't see a big difference with our gunning grade and the shotcrete grade. Here's an example of gunning. So we tried all kind of different machines. Of what you see here on the very left is one of the smallest gunite machines available. It's not
Jens, sorry to interrupt, but you were muted for some reason.
Can you hear me now?
There you are.
Yes.
Thanks, Jens.
Yes.
How much did you miss?
Last
The
minute.
last slide.
Last slide, shall I go back to the last slide?
No, this slide.
Okay,
You start on this slide, Jens.
okay, good. Sorry, I don't know what happened.
Yeah, I don't know where.
So on the very left, you see one of the smallest gunite machines available, and you can gun 7000 series with those machines. So we tested basically all ranges. A good example where you sometimes can't cast anymore, although everything else is cast, and you have to switch to a different method, is an aluminum furnace, where you always have this gap between the roof and to up to the point where you were able to place the material with the bucket in. So in this case, you have to either ram and or gun. And with 7000 series, and it's a really good example, you can use the same material. Our ramming mix is a non-shrink ramming mix. So you won't see any cracks after drying with this material, not like other plastics or ramming mixes. So you also get basically the same properties like a castable, even slightly better, depending on the liquid content. And you can use, you can vary the liquid content slightly, so you can go from a more hand pack to a stiffer ramming mix if you have to work overhead. So the liquid really gives you the variability. Now I can't change my slides anymore.
Nothing changed.
Yes, I don't know.
My guess is something that caused you to mute, and it also affected all the rest of
There
us
you
to
go.
change our
I
muting.
got it.
There you
Yeah.
go.
I think it's just slow.
Yeah, it's slow. My processor is too slow for this. Ramming. So when we started working with these ramming mixes, we did a lot of mock-ups at our plant, and it always included a 45 or overhead, as you can see. And on the right side, you see a good example in a boiler. People who work in boilers know that if you have to fill all these wall boxes, is really a pain, because you have to install a form board on the inside of the boiler, then you have to seal it, and it's hard to seal because you have all these boiler tubes, and then you start casting from the inside, and it starts leaking on the inside, and it's kind of a painful, time-consuming job. So with this material, you just start packing, ramming on the inside. You fill basically the surface up, and then you can cast from the back, from the outside of the boiler, and fill the wall box. I have another picture that shows a little bit. So now let's go to some applications in the industry. A Dross melter door, oxy-fuel burner, very high wear thermal shock on this door. And that door was installed with 7229, so it has some silicon carbide content to avoid adherence. And the drum was lined with 7206. And we used actually the N version in this case. So this is after 1 year in operation. This furnace has been in operation now for 3 years, but this picture was taken after 1 year, and you see that the drum itself is absolutely clean and looks impeccable. The door has some material adhering to it, which is not unusual. And I think they did some maintenance on the door after 1 year, but it's also the first lining still in there after 3 now. Sill application 7229 is it's used in sills quite a bit now. pretty established material for this application. Not only because it can be fast fired, it's also performing very well. And in this case, you see it's been pumped because it's a very large sill. Some other applications here, upper sidewalls on the very left, 7206, a ramp 7206N, and on the very right, this furnace was a total reline with 7206N. But we also came to the conclusion after this installation that the N version is just not as good as our 4L or 2104L. So after a little bit over a year, we started repairing again with our phosphate bonded materials. So my suggestion really is 7206, and yes, upper walls looks good, but wherever you can use our phosphate bond, make use of it because it just gives us better results. Thermbond 7200 in the power industry, coal-fired power plants, biomass, waste to energy. That was our target industry to begin with. Coal-fired CFB boiler, one of our larger installations. We installed 250 tons in this furnace, and we used all methods: casting, ramming, gunning. No, we did not use pumping and shotcrete, but we used casting, ramming, gunning. And that's the advantage of this material. You go into a boiler, you don't really know what to expect until you're really in there. And then you can basically fix everything with one material. You just need the liquid, and you switch from casting to ramming, because sometimes it's just not helpful to climb up 100 feet on a scaffolding if you have to cast a small area and form it all up. Then you can use the same material and just ram it, or furnace rods. Sometimes you can cast those, sometimes you're better off ramming. And this is right after the installation. Typical CFB coal-fired power plant with the coal chutes and support burners. And this is after 1 year in operation. So there was very, very little repair to do.
Hey, Jens,
Yes.
can you speak just a minute about casting the 7200 series in conjunction with the Formula series or our two-component series?
Yeah, so you have to be careful because there's interference between a phosphate bond that is acidic and a 7200 series that is more basic. So you would basically run into issues with setting time, or you could. So what you do normally, what we recommend is either gun 7200 at first, or if you want to or need to cast the Formula series at first, then you basically seal the surface with shrink wrap or something so that there is no liquid penetrating from one to the other. This is a roof, sorry?
Jens, is there much of a drop-off in the characteristics or the properties of the material between the installation methods?
No, it's very consistent. I mean, if you look at the data sheet, on the data sheet, you will see that we publish gun, ram, pump next to each other. And so you see there is a slight variation between gunning and casting, but it's not much. And the same, it depends on the water content. So casting, let's say on average, we recommend 5.5% water. You can cast at 4.8 and you have a kind of a a more vibratable mix, and at 5.5 it's a flowable mix that you can also use for pumping. So you might see a little bit of a difference there, but in general, no, it's not much. And I think we try to be as honest as we could when we put our data sheet together. It really is a reflection on our test results. So here we see a boiler roof left after demolition, and then on the right, it's after the installation. You see brick anchors. It's a pretty high temperature running furnace, and they had a lot of problems with the roof before. And it was cast in 3 panels, relatively high. They used a crane and a tote to cast this. That's the process, and it was helpful. There are a lot of anchors there, and so they that's basically a flowable mix. They did not vibrate a lot there, and you see how it fills up on the between the left, which is full, and the right where it moves up. So you see how flowable the material is actually. And this is after, so I'm not 100% sure whether that is after 3 years in service. I think it was after 2 years in service, but it has been in service for 3 years now.
Yeah. Shemik or Oliver, is this one of your installations?
It's Oliver's.
It's Oliver.
Yes, it's mine. It's now after 3 years, and it works well, no cracks, nothing. It looks very good.
Okay. So what you see here is that on some places it popped off the anchors, but that's really all it is. I mean, it's a very impeccable roof still. Burner box. So I talked about filling up burner boxes and how hard it is. So sometimes when you have replacement, they actually prefer to cast those on the floor because it's easier. Now, you don't have the luxury in a new boiler where everything is basically in a vertical position. So in those cases, you can just weld a couple of anchors to the casing, not to the tubes, because those are pressure tubes and you're not allowed to weld on those, but you can weld small anchors here on the casing, and then in a vertical position, you just ram between the tubes. And this is very well possible with, for instance, 7006. And you adjust the liquid content to a consistency that you can really work with this. Once it's set, you go to the other side, the outside of the boiler, and you just fill the box up with the same material. And that's the easiest and fastest way to do those things. Saves a lot of time. Here an example, it was in a power plant in Warsaw in Poland. So they did a test, 3 different types of materials next to each other because they had so many problems with these burners. And so on the very right, they placed the 7206, one of our first installations. And so this is how it looked after the installation. And this is after 1 year in operation. And you see the difference. It's on the very right is the 7006 material, 7206. And yeah, this is our target. This is our goal to have a fast firing material, but not compromising on performance. You know.
Jens, Claude has a question.
Yeah.
Claude, unmute.
Where is Claude?
Okay, I had difficulty unmuting. Good morning. I just wanted to know, some customers asked, what is the ambient temperature, minimum, maximum for installation for this product? With the Formula series, we can go really, really low in winter and still have great success.
Yes. I have some slides where I will point out to these
Okay.
to this question. Okay.
Thank you.
Yeah. This was also one of our first installations. It was a utility burner, also in a power plant, roughly 3 tons involved. And so they had a polystyrol foam, core foam installed, and they just ignited it. And I was actually shocked when I saw it, but then I was impressed with the thermal shock resistance of this material. So it was a kind of a proof that we did our homework, and it really works in the field. And on the very right, you see the same burner after 3 years in operation, and I think it still looks very good. So again, no compromise on performance, although we have all the advantages of fast firing material. Petrochem. So 7206 was not really developed for petrochem, although we've added now some materials like 7225. And 7206 is also has been used now for burner tiles, as you can see, very complex burner tile. And the reason of using this was that they wanted to have a very smooth surface with very little imperfections. And so we did some tests. These furnace burners are still at a test stage. This is a rotary furnace, rotary calciner. It's in a petrochemical plant and for waste burning. Now, you might think, well, that drum doesn't really look well installed. I mean, you have really patchwork there. But the guys really did a great job because they worked at very, very high ambient temperatures, above 35 Celsius every day. So the material, of course, sets faster at 35 Celsius, but it gave them enough working time to line the furnace and rotate the furnace. So they were actually relatively quick because of that. And the furnace now is also in operation for more than, it's almost 3 years now. And we haven't heard anything negative.
Yeah,
So
this
they were, yeah.
This is an installation in Nigeria.
Yeah, yeah. So, and that shows how resilient the workability actually is. I mean, you can abuse the material quite a bit. Cement industry, our target right from the get-go, we had in mind that with pumpable shotcrete materials, we could really make inroads in the cement industry, and we did. So this is a great example. It's a cement preheater, a Cyclone installation in Europe. It's on the right, you see the cyclones. It's not the plant where we installed it. I just put the picture in here, but it shows very well how the cyclones are located, where the cyclones are located. So when you do shotcrete or gunning, you have to have the hoses high up in the air for the installation. So your pumping mix needs to be very flowable with very little friction to get up there. And here are some pictures from the installation itself. And typical for shotcrete, there's not much dust and there's not much rebound if the material is adjusted right. And the challenge really is, because your installation rate is so high, that you have to adjust the scaffolding with the nozzle man, and because the hoses are heavy and need to be rearranged all the time. Now in this case, they are using actually a large nozzle, and you see he has the nozzle on his shoulder. our materials actually can be shotcreted with the smallest nozzle, which is, I think, an 1.5 inches or so diameter. And that is preferred by nozzlemen because it's not much heavier than a regular gunning nozzle if you have the valve and everything on the floor, not right next to the nozzle itself. And this is the same plant, and it's a roof installation here. So it's all 7229. I think this roof also has been in operation now for 1.5, 2 years or so. And this is a cement plant. It's the ring before the nose block. And that's actually the most challenging application because there's always this push from the furnace lining, which is magnesite and has a very high reversible expansion. So the magnesite lining of the rotary furnace is pushing towards the nose and crushes the ring before or the nose block itself. And in this case, they were installing the material at freezing temperatures. It was very hot, cold, and so they were struggling a little bit with the setting time because it takes longer for the material to set at those temperatures. And what they did here was they basically filled up a section and then they put a metal plate on top of it and secured the metal plate, as you can see on the right. And then they moved on. And then because it was so cold and the material was not setting as fast as they wanted it to be, they had basically sections with these, form material in between. And that was later rammed in place, which in this, again, now with this material, you have the ability to ram it. And on the very right, you see that they put a burner on to expedite the whole setting process a little bit. Well, it worked out, and I think the ring also did its job. Although this is a maintenance item. I mean, there's no way that those rings last for many, many years. It's basically where you have to be on it every shutdown. Okay, brings me to the end of this, and let's summarize what I've talked about. So Thermbond 7200 is one bag and can be applied in different ways. Casting, gunning, pumping, ramming, shotcrete, wet gun. The 7200 liquid turns a self-flow castable basically in a ramming mix and gunning mix. So that makes it so flexible. So if you want to make use of the flexibility, you have to order the liquids. The liquids have a shelf life indefinitely. So there is not that you have to throw it away after a year or so. Makes job site planning easy because now you only need one material plus the liquids and you have all the flexibility that you need to finish a job. So the one material serves different installation purposes. Fast firing without compromise. I think that's what we've seen so far over the last 3 years. The material is on the market roughly for 4 years now when we started it. And we have already a proven record with well-performing linings. And our ultimate goal, large installation in cement and power performed with all installation involved. So, and I can end with saying the concept works. So thank you.